So transformations of exponential functions. Just like everything else we've done function-wise, there's a way to move it around the graph. It doesn't have to stay just where the parent function, which was a lot what we were working on yesterday. Y'all got to see the y-intercept change yesterday. How did the y-intercept change? By what? The a would change. So if the a was different, then your y-intercept is changed. And so when we have f of x equals a times b to the x minus h plus k. And we're going to figure out what each of these parts will do. So I'm keeping the same letters. Your book is actually going to use different letters, but I think the H and K, I like to keep them in the same, because we've seen H and K before as the vertex. And that's the left and right shifts that we'll be having. So let's think about things that we had showing up in our graph. When every single time we had a graph where we had a y equals 0 asymptote, and we had a y-intercept at 0, 1. These are the things that you'll be looking at moving around. These are the things we'll be looking at shifting, stretching, compressing. And so these are our key points that we'll be moving around the graph. Also, the graphs went like this mostly, correct? Or this. So we could reflect that as well. So our first set we're going to look at is f of x equals 3 times 2 to the x, and f of x equals 1 times 2 to the x. And look and see what's different between those two graphs. Assuming that you have got this graphed, what things are different?
The y-intercept.
The y-intercept. The slope. It's like the blue one has been stretched up, and that's called a stretch of 3. So that's because that number is greater than 1 is a stretch. Okay? Because the 3 is greater than 1, it's called a stretch. Okay, what do you think is going to happen if I got you to graph f of x equals 1/3 times 2 to the x? Graph that in the third equation. The y-intercept is going to be at that 1/3 mark. So instead of stretching that out, we compressed it down. So that 1/3 is less than 1, and that's going to be a compression. And so this is all talking about a vertical stretch and compression. There's actually, you can do it the other way with stretch and compression, but we're focused in on vertical.
So if A is smaller than 1, it's a compression. If A is bigger than 1, it's a stretch.
So if A is smaller than 1, it's a compression. If it's bigger than 1, it's a stretch. Yes.
Does the first number determine the y-intercept?
It does determine the y-intercept if there's no other transformations.
Okay.
So normally we start, without anything else, we're going to start at the y-intercept of 0, 1. If we have an A, then we're in 0, whatever that number is. And then we'll move our left and rights. That's just, I wanted to start here, because this is how we determine our starting value. that a is really your starting value when you're actually doing equations and writing equations. And so on this next one, we're going to look and see what happens when I do f of x. And again, I'm trying to keep it to where we're not having too much crazy going on, so we're going to keep pretty consistent on some of the parts. X plus 1 and f of x 2 to the x. And just, I'm trying to keep it to where we're not having multiple transformations in each one, so we can see what that one little piece is doing. So when we do this, on these functions, it's almost hard to see what's actually really happening. So we have to look at it in a different perspective. And that line didn't show up very well. Let me get a different color. Okay. This is y equals 1. So at 0 on the original graph, we crossed. It's at this point is -1, comma 1. So what happened to get that transformation? What did we really do? What did that adding 1 to the exponent do?
Change the slope?
It didn't change the slope. It moved it to the left.
Oh.
Because we're looking at it from a different perspective and this line keeps growing, it almost does appear as the slope changes. It doesn't. It just shifts it left. So this caused us to move left 1.
So if you did -1, would it move to the right?
Let's find out. And so try that in your calculator. So when we had f of x equals 2 to the x minus 1, instead of going left 1, we went right 1. So the exponent is going to move us left and right. So f of x equals 2 to the x. We're going to do that as one of them. And f of x equals 2 to the x plus 1, not in the exponent. So on this one, our original, again, with the y-intercept is 0, comma 1. What's our y? This time, we moved up 1. These are harder to see than when you have a quadratic and a cubic even and a absolute value, because there's not that vertex to identify from. And that's the reason we usually don't start with these guys. We start with other things on transformations. Because this is a continuous line that doesn't have a sharp turn or a turn at all, and it's hard to see, identify the points. So what do you think if we did f of x equals 2 to the x minus 1, not in the exponent? Where do you think it's going to? Down 1. If you want to graph it to see that, you can. And the last transformation we are really going to focus in on is the first one we're going to graph is f of x equals 3 times 2 to the x, and f of x equals a negative 3 times 2 to the x.
Can we clear our graph?
Yeah. You can clear your graph each time. So what did change in the sign in front do?
Flip.
It reflected over what?
Overflected by the x-axis.
What do you think would happen if I put a negative in my exponent? Which axis do you think it's going to reflect over? The y. So if you have f of x equals 2 to the x and f of x equals 2 to the negative x, this is a reflection
Did that flip it?
over y.
Did that reflect over the x-axis?
The first one did. This one reflects over the y. Okay, the rest of the period is yours to work.
So if you change that
Is that what it is here?